Hi, hello everyone. Welcome. I'm Sara Hillel. I'm really excited to be here today. So thank you for joining me here in my talk, Reason and React with ReasonML. With us today is Danny Friedland, the CTO at Walnut. He joined us for answering questions you might have, so feel free to ask. My talk is about the story of ReasonML. We'll have a short journey here together in the next 25 minutes. We will navigate through the three questions of why, what, and how. We'll start with why. Why we even need ReasonML? What is the current situation with web development that makes us considering ReasonML? And for answering it, we will take a look at four paradigms I've observed in modern web technologies in recent years, and we'll see how they affect the decision about which stack to use. Then we'll get to know the what ReasonML is, what the story behind it, who created it, when and where. And in the last part, we'll discuss how to use it, how it looks like. We'll see some code snippets and learn some concept and feature of the language. And we'll discuss also how it might help us. We'll see two real-world use cases and discuss how choosing ReasonML was a smart decision for them. So let's start. First of all, I'm Sara Hillel. I'm a software engineer and a digital nomad. Currently, I'm based in a farm in northern Israel. The background of the slide is my office view. And I work at Walnut, where we build no-code platform for creating sales demos for sales leaders. Previously, I worked as a freelancer for several years. So for most of my career, I worked with early-stage startups. As an engineer, especially when building application from scratch, you have to make so many decisions with enormous impact. It starts from the very beginning with questions such as, how do you even decide on the stack? And to be honest, it's a hard decision. In recent years, it has become even harder. We have so many options to choose from. But how do we know? How do we know what will work for us? What will make our code maintainable and scalable? What will make our work fun and productive? So while doing that and choosing stack again and again over the last years, I've noticed that modern web technologies are evolving towards four trends. The first one is easy. There is no paradigm shift here. For the browser, JavaScript was and is a standard. Always bet on JavaScript seems to be accurate for the near future, whether you like it or not. The second trend, static typing. More than ever before, developers want statically typed system. In the context of type system, dynamic means at runtime, while static means at compile time. So the type of a variable is known at compile time. Some type languages require you as a developer to specify the type of each variable. Other languages make use of type inference, the ability of the type system to derive the variable type. Either way, static typing has a big advantage over dynamic typing, since checks can be done by the compiler and many trivial bugs will be caught way earlier. Next, our third trend, functional programming. And to see it in action, I want us to take a look on one tool that has kept shining over the last years. And I'm talking about React. React is a declarative, efficient, and flexible JavaScript library for building user interfaces. And it is popular, very popular. When I try to explain its popularity, I think about how it makes me code. And for me, React is like a bit of success, where it's easy to do the right things and annoying, but not impossible to do the wrong things. Let's try and see in the code. So this is component. React is component-based. Everything is made up of components. You build encapsulated components that manage their own state, then compose them to make complex UIs. Components can receive inputs, the props. Props are immutable. You can read them, but you cannot change them. Granting immutability prevents side effects, which make your code more predictable. It's simpler to understand and easier to debug. Composing components give you a hierarchy, which facilitates a unidirectional data flow. So composition, immutability, unidirectional data flow are all functional techniques that make you reason about your code. And this brings us back to our third paradigm, functional programming. So we've reached the last one, a concept which attracts many developers and companies. And this is learn once, write anywhere. Web, mobile, desktop. The canonical examples here might be one, React Native, for building iOS and Android apps with the knowledge of React, JavaScript, web developer, and two, Electron, for desktop apps, again, with the knowledge of web development. So all four of these trends are influencing web technologies today. And my question is, what have we got so far from these trends? And as I see it, we've got JavaScript with patches. A patch for static typing, a patch for immutability, a patch for functional programming. You find yourself bike shedding with configuration and endlessly adding and learning libraries and frameworks. Is there any other way to do it? Like, why not just focusing on code? Well, meet ReasonML. And we'll jump right into the code. It looks familiar, right? It is exactly the same React code we've just seen, but now it's written in ReasonML, so it's static typed. You might ask, where are all the types? Great question, we don't see them here. And that's the beauty of ReasonML. It has a sophisticated type inference system. So what is ReasonML? ReasonML, or Reason, was created by the same guy, Jordan Walke, who created React and React Native at Facebook. It was first appeared at 2016, after the creation of React and React Native. So is it a new language? No, not exactly new and not exactly a language. It's a new syntax on top of the established OCaml language that is meant to be familiar to JavaScript developers. So basically, Reason is OCaml with JavaScript syntax, and both Reason and OCaml can be compiled to JavaScript with Bucklescript, a blazing fast compiler. You may be wondering what ML in ReasonML stands for. So clearly not machine learning, right? So ML is an abbreviation for meta language, which is a functional programming language. It might be known for you from your academic studies, and it's best known for its use of the Hindley-Milner type system, which automatically assigns the type of most expression without requiring explicit type annotation, or in other words, type inference, as we've just seen in the code. Today, there are several languages in the ML family. OCaml is just one of them. And by the way, another language in the family is StandardML, and React was originally designed in StandardML. Okay, so if we say that ReasonML is just OCaml, let's talk a bit about OCaml. OCaml is a battle-tested functional programming language with more than 20 years of type theory. So it's not a new language at all. OCaml is pragmatic. It defaults to immutable and functional code but allows escape hatches into imperative code when you need it. So for example, you can declare variable as mutable, but you have to explicitly state, I want this to be mutable. So Reason has the exact same AST, also syntax tree, as OCaml, the data structure that represents the parsed code. They only differ by the syntax. And both can be compiled to JavaScript directly in the browser with BackLScript, or to native code, or to bytecode. So the workflow we describe here on the left side is like this. 1. Write ReasonML code in files with RE extension. 2. Parse ReasonML code into the OCaml AST. 3. Type check and compile AST to produce JavaScript code. You can do it with BackLScript. And last, bundle JavaScript code to produce static assets you can use on the web or in Node.js with any tool you choose. Webpack is just one of them. So if you're writing ReasonML, you really don't see OCaml code at all. And the JavaScript that comes out the other end is quite readable and pretty optimized. Alternatively, you can use the newer script, which is a rebranded ReasonML with BackLScript. That means that in this case, you write a ReScript code in files with the extension of RES, and the underroad workflow is simpler, but usually you won't feel the difference. Okay, so let's see what we've learned so far about ReasonML and summarize our what section. What is ReasonML? So ReasonML as a language is as mature as OCaml, and OCaml is about 25 years old. ReasonML is also safe. Generally, when we aim for safety, we want a type language that is sound, so we know that the types are not lying. In that respect, ReasonML is safe. It has a static typed system with soundness guarantee, giving you 100% static type coverage. And it's important to note that while TypeScript and the like will help us with types most of the time, its type system is explicitly designed not to be sound. So you don't be able to get guarantees. What else? ReasonML is immutable and functional by default, but it's also pragmatic. It encourages pure functional code but allows imperative code when needed. So sure, we have the benefit of sound typing and functional paradigms, and they are all great. But is it really worth the overhead of learning a new language? In the case of ReasonML and its familiar syntax for those who are migrating from JavaScript, the overhead is minimal. So the language is ergonomic, and it's also ergonomic in terms of readability. Types are inferred, so the code is not verbose. Also, the compiler catches your errors and shows you exactly where to fix it, so the feedback loop is getting shorter. You have fast and performant compilation into efficient and relatively readable JavaScript code. And last thing, in case you need it, you can write once and run anywhere, not only on the web. Amazing. So now that we know pretty well what is ReasonML, we can move on and discuss the how. Our first how is how to write ReasonML. We know the syntax, and we know it resembles JavaScript, but what else do we need to know for coding in ReasonML? So let's have a look in some of the language gems that might be unfamiliar for JavaScript developers. One small thing you might see here in the slide is the tilde prefix for arguments. This is for label arguments or name arguments. This can be helpful when dealing with many function arguments or arguments with the same types. And because the arguments are named, the calling order can be changed. But the main feature in this code is variant. Variant is the data structure that enables you to choose from a variety of options. Most data structure in most languages are about this and that. A variant allows us to express this or that. So in our case here, topic is a variant type with the cases front-end and back-end. They are called variant constructors, where the bar separates between them and they must start with an uppercase later. Cool. Variant constructors can hold extra data. For example, here, the front-end topic can store the language name, a string, and in our case, when we use it, it is ReasonML. When you combine variants with pattern matching, you get a powerful combination that lets you execute some code based on the shape of the data. So here we avoided messy if-elses and got a clean structure of code which is also compiler verified. Let's see what it means. So here, what happens if we add a constructor to the variant or miss a value in our pattern matching? Exactly like we do here, we added the DevOps constructors. And in this case, we will have a compile exhaustiveness check, which will save us from these bugs. And it does it in a very expressive way, as you can see. It tells you in which line you were wrong and what branch you missed, DevOps. Okay, one last powerful feature I want to show you is option. But before that, let's explore the code in this slide. In this code, we use a record. Records are a structure used for storing data in named fields. Very similar to objects or struct in other languages. And in order to use a record, you must first declare a type for it. Once you do it, the speaker record can be created and the correct type will be inferred. It does not have to be annotated, so me and speaker argument both are inferred to be from a speaker type. Now, what should we do when a speaker has a name, but not necessarily as company? In Reason, there is no null value at all. Instead, if you need to indicate that a value might or might not be available, use the option type. The option type is a variant with two constructors. None represent the absence of a value, and some represents the presence of a value and accept that value as an argument. So here we converted company to use option, and now we need to handle its usage in the commented outline, this one, since it's not a plain string anymore, so this line is not longer valid. So what can we do? One thing we can do, we can use option as a variant and adjust our output to the situation. So the first branch here in the pattern matching is for a specific company. The second, it's the general case. And the third, where there is no company. So we covered all cases. Okay, so we are close to end, and I'm sure you have more questions than you had before the beginning of this talk. Question like, is it ready for production? Do you recommend it? Is it hard to learn? And I want to tell you about two real-world use cases, and I hope it will address some of the questions, or at least will make you curious enough to explore more on your own. So the first use case is about a common application from a big company we all know. It's the Messenger app by Facebook. The second is a startup where I work, Walnut. So we learn some lessons from both. Let's start with the Messenger app by Facebook. They released some statistic in about 2018 or 2017. After refactoring 50% of the Messenger app to ReasonML. They review parameters regarding quality of code and developer experience, and the numbers are stunning. You can see here, for example, instead of getting bug reports on a daily basis, we got 10 bugs, not per day, not per month, per year. And only in the section which was converted to ReasonML, of course. And they also significantly reduced the refactoring time and build time. Another use case is ours at Walnut. I have no references since we started with ReasonML from the very beginning, but I can say we have a great onboarding process where anyone who join us without any prior knowledge of ReasonML or the code base is able to push to production in just a few days and to make wide refactoring in a few weeks. I can say that the trust and the confidence we have in the code base is part of this success. Also, we do have some logic errors in our apps from time to time, but we no longer have any technical bugs. And in fact, when opening a report of the top 10 errors in JavaScript, errors we are all familiar with, like undefined is not a function, or type error, and null is not an object, I realize that I'm not encountering this error anymore. So this is fun. Okay, that's it. Our journey has ended. And to summarize, we saw 4 trends in web development: compiling to JavaScript, static typing, functional programming, and using the same code for different uses. ReasonML and the new rebranded REST address them all inherently. And that's the why we need it. We had the opportunity to learn what is ReasonML, a JavaScript syntax for the OCaml, a statically typed functional programming language. And then the how ReasonML affects 2 companies, Facebook and Walnut, and how to do things in ReasonML. Options, variants, pattern matching, and more. I hope you're ready to explore more on your own. Here are a few links that might be useful. You can play with Reason in the browser, consult with others on Discord, add it to JavaScript, to exist in JavaScript project, or start it from scratch. You are more than welcome to contact me. It is Sara Hillel on most platforms. And thank you. Thank you very, very much for joining me. And thanks to the team of this great conference. Also thanks to my coalition of women and men for supporting, providing feedback, and making this talk happen. Special thanks to Danny Friedland, who is here with us, the one who answered your questions on the chat, and also the one who introduced me to ReasonML, and provide me the best playground for experiencing it. So thanks, enjoy the conference, bye-bye.